Hey everyone, let's dive right in. Welcome to This Explainer. Today, we're tackling a massive headache that, honestly, every IT support engineer and QA tester out there knows way too well. We're going to do a fast-paced, super practical walkthrough on how to completely bypass back-end downtime using Postman mock servers. So if you've ever been totally stalled out because a system you rely on just isn't ready, well, you're definitely in the right place.
Let's picture this scenario. You're trying to test a critical integration, or maybe validate a really important bug fix on the front end. But there's a huge problem. The backend payment API is just completely offline. Or, maybe it's still being built by the backend team who swore it would be done by Tuesday, right? So what happens? Your entire support or QA workflow is just blocked. You can't test the front end because it literally has nothing to talk to. It's a universal, incredibly frustrating bottleneck, and it wastes countless hours of productivity.
But there's a fix. The Postman API platform documentation actually states it perfectly. Mock servers remove the backend from the critical path. Honestly, this is a total game changer. Instead of just sitting around waiting for the backend to be fixed or finally finished, we can use Postman to spin up an intelligent simulation tool, a mock server that behaves exactly like the real API. And the best part? You can do this whole thing entirely on a free Postman account and just keep your work moving.
So here's our roadmap for today. 1. The broken backend problem. 2. Building your request collection. 3. Launching the mock server. 4. Testing the mock endpoint. And 5. Unblocking the support workflow. All right, let's get right to it.
Section 1. The broken backend problem. Simulating the payment API. We desperately need to test how our front end handles 404 and 500 errors, but the real API is down for maintenance. So, we simulate it.
Moving to Section 2. Building your request collection, setting the foundation in Postman. Before we can simulate an API, we first need to build a blueprint of what it should actually look like. You can really think of this collection as the contract between your front end and your fake back end.
Setting this up takes just a few clicks in the UI. First, you're going to click New Collection over in your Postman sidebar and name it something obvious, like Payment API Mock. Next, add a sample request to it. Let's make it a GET request to a path called /charge. Now, here is the absolutely crucial part. Instead of clicking Send, you want to select Add Example or hit Save Response if you've already run a test. This saved example right here is what acts as the foundational contract for our mock.
Now keep in mind, a mock server is only as smart as the examples you actually feed it. To truly test our front-end error handling, we need to populate our collection with a few diverse edge cases. So we'll build one example for a 200 OK simulating a successful transaction. Then, we need a second example for a 404 not found. That simulates an invalid payment ID. And finally, we're going to add a third example for a 500 server error, just to simulate a total back-end outage.
Let's quickly break down what we're actually doing in the Postman editor here. A saved example is literally exactly what it sounds like, a predefined response. You just type out the JSON payload you want the front end to receive. You manually set that status dropdown to 200, 404, or 500, and you just type out the fake JSON body, something simple like status failure. Basically, you're explicitly defining the exact data the mock server is going to hand back when it gets called.
All right, Section 3. Launching the mock server, navigating the creation wizard. It's time to take those static examples and bring them to life.
Postman makes this part incredibly fast with their creation wizard. And again, remember, you can do all of this right on the free tier. Just navigate over to the left sidebar and click Mock Servers. It's going to ask which collection you want to simulate. We'll choose our Payment API collection, give your mock server a quick name, and finally, just hit that Create Mock Server button. Boom, that's the whole shebang. Postman handles all the cloud hosting in the background instantly.
And right here is the ultimate payoff. Postman instantly generates a unique public mock URL just for you. It usually looks like HTTPS followed by a long string of numbers and letters, then .mock.pstmn.io. This URL is absolute gold. This is the fake address you're going to hand over to your front-end application to route all of your testing traffic toward.
Section 4. Testing the mock endpoint. Routing traffic to the simulator. Now let's actually put our newly generated mock server to the test.
So the really crucial step here is swapping out the destination. Your front end or your API client was originally trying to hit the real api.payments.com/charge, which, as we know, is currently down. You literally just delete that base URL and paste in your shiny new Postman mock URL.
but you keep the /charge path exactly the same. You're basically just rerouting traffic from a broken highway straight onto a freshly paved, simulated road.
Now, jump into your testing environment, or honestly, even just open a new tab right there in Postman. Paste in your mock URL with that /charge path and hit send. Instantly, you're going to receive the exact 200 OK JSON response you designed earlier. Honestly, it's such a satisfying feeling. Your front end has zero idea it's talking to a mock server. It just sees valid JSON and keeps right on functioning.
Now, you might be wondering, how does Postman actually know which of our 3 examples to return? Well, it uses a pretty smart matching algorithm. First, it looks at the HTTP method, like are you sending a GET or a POST? Then it looks at the path. Is it /charge? But here's the real pro tip for testing those tricky edge cases. If you want to force your mock server to return that 500 server error you saved, you just slap a header onto your request called xMockResponseCode and set the value to 500. Postman sees that header, grabs your 500 example, and fires it right back. It gives you absolute, total control over the simulation.
Which brings us to Section 5, unblocking the support workflow, mission accomplished.
Let's bring this all back to our original problem. As Eduardo Iriarte Mendez points out, tools like this allow development, testing, and releases to be run in parallel. By spending, maybe 5 minutes setting up a mock server, you've completely bypassed that back-end outage. Your front-end testing can just continue. You can trigger those 404s and 500s on demand, validate your app's error handling, and make sure your bug fixes work without missing a single beat. You're no longer stuck waiting on someone else's system.
So I want to leave you all with a bit of a provocative thought here. If you can simulate literally any back-end failure state, any weird timeout, or any bizarre data payload in just 5 minutes using a free Postman mock server, what untested edge cases are hiding in your front end right now? Seriously, don't wait for the live API to break to find out. Go spin up a mock server today, start throwing some simulated errors at your application, and build a more resilient system. Thanks so much for joining me for this explainer, and hey, happy testing!